Hey, Algebra 1. So yesterday we talked about how to factor a trinomial, and those were fairly straightforward. I feel like a lot of your work reflected some understanding there, so that's good. Today we're going to talk about difference of squares, and these are a little bit different, I guess. So we have two documents here. We have the notes page that has, pretty much everything I'm going to say, and then also some examples that we'll do together. I know that there's 5 of them. I promise it's not going to take that long. Once we get the hang of this, it's going to go super duper fast. Then you have 6 questions over here on your own worksheet. Again, these go pretty quickly, so let's get started. So we remember multiplying these. And when we did this, we came up with x squared plus 4x minus 4x minus 16. And then that middle term, those middle terms, the plus 4x and the minus 4x, those canceled off to be 0. And so we got x squared minus 16. That was the special case when the middle term canceled out whenever we combine them like that. So that's what we're looking at today, those special weird things. And so let's look again really quick at this one. That's going to be x squared plus 7x minus 7x, and positive 7 times negative 7 is negative 49. And so when those middle terms cancel out, we're going to have x squared minus 49. And that's it. Okay. This one has, coefficient on the variable term, and so that's a little bit weird. But 2x times 2x is 4x squared, and then minus 6x plus 6x, and that 6 is coming, remember, from 2x times 3 and negative 3 times 2x. So I guess I technically did those backwards if you want to nitpick there, but the order doesn't really matter as long as you're multiplying each one by each other. So anyway, and then 3 times negative 3 is minus 9. And so then again, the 6x and the negative 6x cancel each other. And so now we have 4x squared minus 9. Sorry. So here's the deal. What happens in each one of these? We're multiplying binomials that are almost identical except for the plus or minus right here, plus and minus, minus and plus. So what's happening in all of their multiplications and all of their final answers? Well, we got x squared minus 16, x squared minus 49, 4x squared minus 9. So all of them are subtraction. Okay, they only have the squared term and the constant. And look at all these constants real quick. 16, 49, 9. Those are all perfect squares. And then if you look at the first term, the x squared term, we've got x squared. That's a perfect square too. We've got 4x squared. 4 is a perfect square. And so both of these terms are perfect squares. And that's why we call them difference of squares. And we'll get to that here in just a second again. So let's factor these. Remember that factoring means breaking it down into stuff that multiplies equivalently, because that's what a factor is. A factor is a multiplier that, when put together, multiplies to be the other number, like 2 and 3 are factors of 6. So what are the factors of, let's say, x squared minus 81? So yesterday we used the x method. So trying that, we find two numbers that multiply to be negative 81 and add up to be something. That's right. When there's no middle term, that's a 0x. And so our middle term is 0. So what two numbers multiply to be negative 81 and add up to be 0? Well, that would be 9 and negative 9. They have to be inverses of each other to additive inverses, I guess I should say, to add to be 0. And so this specific type of factoring is called the difference of squares. Each term is a perfect square. We talked about that. And difference means subtraction, so difference of squares. This is highlighted. I wanted to highlight it in red, but it was very difficult to read. You know what? Let's do that anyway. Let's highlight that in red and make it bold. This is not to be confused with sum of squares. Those are not factorable because there's no two numbers that multiply to be positive 81. You're thinking 9 and 9, right? Yeah, I see you. But those don't add to be 0. They add to 18. And so, real quick, if we were going to say x plus 9 times x plus 9, say that that's our factors, what we would actually get here is x squared plus, that's not a plus, sorry, plus 18x plus 81. Dang nabbit. Plus 81. That is not a difference of squares. This is what happens when you multiply the same thing by itself, but there's no sum of squares like that. In Algebra 2, you're going to get to sum of cubes, but I'm not even going to confuse you with that right now, so let's walk away from this. Sum of squares is not a thing. When there's a plus in between those two terms, you cannot factor it. You have to write the word prime, which means it is only divisible by 1 in itself, and then move on. We will learn how to deal with the sum of squares later on. We're going to get a special formula. It's going to be probably one of the last things that we do whenever we're learning how to solve quadratic equations. It's actually not too bad. But right now, just write prime and move on. So here's our examples. I'm not even going to use the equation editor here because I'm just not going to take that time. So how we do these, simple steps. Take the square root of the first term, take the square root of the second term. The square root of x squared is just x. And okay, so we're going to have our parentheses ready to go. All right, so take the square root of the first term, we got it, put that at the front of the parentheses. You're going to have 1 plus and 1 minus because that was the setup that we saw up front or up top. Okay, and then the square root of the second number. The square root of 36 is 6. That goes here. And if you want to make this, really neat, sorry, that's just me thinking while typing, x plus 6, x minus 6. And that would be your final answer. Okay, let's do a couple more. This has a coefficient up front. Oh no! Not a big deal. Okay, so again, 4 is a perfect square. And so I can take 2x, there we go, plus, and the square root of 81 is 9, and then 2x, good gracious, minus 9. So again, the square root of the first term goes in the first spot on the binomial, plus and minus automatic minus sign, right? On plus and minus. And then the square root of the second term, which is 9. Okay, great. Moving on. 16x squared minus 1. Does this even qualify? Well, 16 is a perfect square. X squared is a perfect square. Is 1 a perfect square? 1 is that perfect square that everybody forgets about, right? So this would be a difference of squares. 4x plus 1 and 4x minus 1. So far, I've written them all plus 1 and then minus 1, or plus this and minus that. It doesn't really matter which order you put those in. Just in case you were wondering, this is just my particular technique, whatever. It does not matter which order you put them in, if it's plus first or minus first. Okay, next one. 12x squared minus 25. Okay, what's the square root of 12? and somebody is there with the calculator open and like, it is 3.72895. No, it's not. No. I mean, like, it might be, but for our cases, no, it's not. There is no square root of 12 to where it would make doing this reasonable. So what we're going to do here is we're going to write prime, because 12 is not a perfect square. 25 is. And next week, or the first thing that we're going to do next week, is look at greatest common factors and make sure. But 12 and 25 don't have any factors in common. And I did that on purpose, so that there would be absolutely no confusion about this. But yeah, the 12 and the 25, they have nothing in common. 12 is not a perfect square, so we can't factor this one using our tools here. And we couldn't factor it using the Xbox method, which we will also learn next week when there's a lead coefficient that's not 1. Okay. And then we've got this one, x squared plus 100. So what's a square root of x squared? Oh, have you caught me yet? Okay. Yes, this is an addition problem. We cannot factor this because there's no two numbers that multiplies to be 100, but adds up to 0. 10 and 10 multiply to 100, but they add to be 20. 4 and 25 multiply to be 100, but they don't add anywhere near 0. So this, again, is prime. Did I put each of those on your worksheet? Probably, because I'm a jerk like that. And I want to make sure that you think. So please watch out for that kind of stuff. But these are the examples. Again, nobody is really communicating with me here, so I don't know if you guys are super duper comfortable or if you're all just, Googling the answers, but whatever you're doing, please let me know if this is okay or not. These you might find challenging to Google the answers, by the way, because I made these up 5 minutes ago or however long ago I started talking. All right, so there's that. This is your assignment. It is 6 problems. It is due at noon tomorrow. And I will have the late work updated tomorrow if anybody has been turning in late stuff. And then I will update the grade book for this week's assignments on Friday. That's right. You guys are watching this on Thursday. It is almost 10 o'clock at night on Wednesday that I'm making this movie. So I don't know. All my words are coming together. All right. So there you go. There's that. I'm going to walk away and let you guys get to work. All right. You guys have a great rest of the day. Have a great weekend. Enjoy Saturday. I heard it's going to rain Sunday, but whatever. We need some. So we'll see you later. Bye-bye.